Hello and welcome to this tutorial. For the past tutorials, we have been looking at different topics under calculus, and this tutorial we're going to be looking at functions from real numbers to another real number. This tutorial might probably be a long one, so I might divide it up into 3 parts. In any way, this is going to be the first part. We are going to have 2 additional parts coming after this. For this first part, I'm going to be looking at general overview of the concept of mappings and functions, and different characteristics and different definitions associated with mappings and functions. In the second part, I'm going to be looking at types of functions or types of mapping. And in the last part, I'm going to be looking at different examples and problems associated with mappings and functions. So as I mentioned in this part, we are going to be looking at general overview of the concept of mappings and the concept of functions. So let's get straight into the tutorial. So we're going to be looking at the functions from real numbers to another real number. So to give an overview of what this is going to be and what we're going to be looking at for the next 2 tutorials, let's take a square for an example. We have a shape here which is a square. For square, we know that all the sides are equal. So if I have x here, this is also x, and this is also x, and this is x. And we define the area of a square A to be x squared. So we can say that A depends on x. We can say that A, so let me use a more vibrant color here. So we can say that A depends on x. So the solution to A depends actually on x, and in this case, we just raise x to the power of 2 and we get our answer for A. So we can say that A is a function of x. So we can say that A is a function of x, and this is the general overview and a general big picture of the concept of functions and mapping. So again, here we have area to be equal to x squared, and A depends on x. So we can say that A is a function of x. Another example, if we say that y equal to 2x plus 3, we can also say that y is a function of x, and in this case we simply take x, multiply it by 2 and add 3, then we can get y. So here we can say that y is a function of x. So we are now going to be looking at different definitions on how we can illustrate this point better. Moving straight to the first definition, we have that let A and B be any 2 non-empty sets if there is any rule which assigns to every element of set A one and only one element of set B, then the rule is called a function or mapping, denoted by this. So what are we trying to say for this definition? So let's say, for example, we have a set A with the following elements: 2, 3, and 4. And if you check the definition, it says that let A and B be 2 non-empty sets. We know that our set A and set B are non-empty sets. So if there is any rule which assigns to every element of set A one and only one element of set B. So if I have a rule which assigns the element of set A to element of set B, and if I have the element of set B as this, here I have 4, 6, and 8. So if there is a function which assigns to elements of set B from an element in set A, if I have a function A, so we define this f as a function. We check back from the definition, then the rule is called a function or a mapping, which is read as this. So if you look at this particular set, you have this as set of A and also this as set of B. So if you study this very well, we are going to see that B is simply 2 multiplied by A. So if you multiply each element of set A, we are going to have this. If I multiply 3 by 2, I'm going to have 6, and if I multiply 4 by 2, I'm going to have 8. So meaning that we have a function which assigns an element from set A, another element in set B. So by simply taking the multiplication of set A by 2, we can get set B. So we refer to this as a function of A to B. So we say that f is a mapping from A to B. And that way that we can read it, is if you write y equal to f of x. So we simply say that y is a function of x, and this one is treated as y is a function of x. So this is what we can get from definition 1, that if you have a function which assigns to every element of set B, which assigns to every element of set A one and only one element of set B, then the rule is called a function or a mapping, and it's denoted with this. And this is simply read as f is a mapping from A. In this definition, we are going to be looking at the concept of image, and we have the definition that goes thus: let f is a mapping from A to B be a function. If A is an element of set A, then f of A is an element of set B, and f of A is called the image of A under f. So to illustrate this particular definition, we have to go back to the former definition. Here where we have set A and set B, and here we have three elements of set A, which are 2, 3, and 4, and another three elements of set B, which are 4, 6, and 8. So in this definition, we have that if you have A, which is an element of set A, so if you have a small letter A, here we can just pick any element of set A. So here if I pick 3, if I say A equal to 3, and don't forget, we define this particular function as B equal to 2A. So using the same function, so we have that B is a function of A, and in this case we have that B equal to 2A. So if you pick one element of set A, as we have here, which is A, is an element of A. So here I pick small letter A to be 3, which is an element of set A. Then f of A is an element of set B. So what will be f of A in this case? We're going to have f of 3. And f of 3 is simply putting 3 where we have A. So this is going to be 2 multiplied by 3. Here we have 6. So we can see that 6, which is the answer here, is an element of set B. Going back to the previous example, here we have that 6, which is an element of set B. So we can also note that this is true. We have f of A to be element of set B, and f of A is called the image of A under f. So we can see that whatever we get as f of A is the image of A under f. So in this case, we have that f of 3 equal to 6. So we can say that 6 is the image of 3. And this is the concept of image. So going back to the previous example, so we can say that here 4 is the image of 2, 6 is the image of 3, and 8 is the image of 4. So whatever you substitute as your f of x, so whatever the answer is the image of that particular substitution. So for any two non-empty sets, whatever the answer is after applying the function is simply the image of that particular element. Just like we have here that after calculating 2 multiplied by 2, we have 4. So 4 is the image of 2. So that's the concept of image under mappings and functions. Let's look at another definition. Definition 3. The set of all acceptable inputs of a function f is called the domain of f. In other words, if f is a mapping from A to B is a function, then set A is called the domain of f, and set B is called the codomain. So one very terms we hear in the concept of function and mapping is the word domain and codomain. And to illustrate this, let's consider two sets. So here we have a set A, set B. So I'm not going to be using the example we're using before. I just have another example here. So if you have set A and set B, and we have this to be defined by a function f, and we define f as a function from A to B. So here I can simply define that my B equal to A plus 1. So if I have this function defined as B equal to A plus 1, and here if I have 1, I'm still going to have A plus 1 here can be 2. And if I have 5A, so this is going to be 6. And if I have 7 here, this is going to be 8. So here I have my function defined as B equal to A plus 1. So the set of all possible entries that can go into A is called the domain. So we call this the domain of the function, and we call the set of all B the codomain. Another concept we're going to be looking at later is the range, so which is always a subset of the codomain. But for now, let's take note that every possible values of set X or set A is the domain, and the resulting image, the set of all the images, is the codomain. For example, if you have a more general function as f of x equal to 2x plus 3. So every value that we substitute as x is the domain. And whatever this is, the set of all this is the codomain. So just like we have here, we have 1, 5, 7 as all the sets of A, and B to be 2, 6, 8. So the values we have inside A, they are the domain, and the elements we have inside B, they are simply the codomain. So now let's look at another example. This definition, we are going to be looking at the concept of the range, and we have this defined as the set of all outputs of a function f is called the range of f. In other words, the set of those elements which appear as an image is called the range of f. There is usually some misconception between range and codomain. In the last definition, we look at the principle of codomain, and we say that if you have set A and set B, and there's a function that maps sets A to set B. So here, if you can have this to be 1, 2, 3, and this to be 3, 4, and 5. So here we can say that B equal to A plus 1, and we are going to get all the elements that we have in B. So we say that A is the domain and B is the codomain. But sometimes, due to nature of mapping, not all the sets in B will be an image to elements of A. So not all the elements of B will be an image to elements of the set in A. So the set of all the images is simply refers to as the range. For example, if you have this, if you have a set M with the following elements, 2, 3, and -2, and we have the sets of set N to be 4, 9, and 16. So we know that all the elements in M are the domain and all the elements in N are the range if there's a function that maps M to N. And here we can see that the image, if we define this function as N equal to M squared. So we know that the square of 2 is 4, the square of 3 is 9, and also the square of -2 is still 4. So we have that even though we have the elements 4, 9, and 16 to be the codomain, the range is simply 4 and 9 because they are the ones that are images of the elements in M. So we say that the range, we have the codomain to be the set 4, 9, and 16, but the range for this particular mapping is simply the element 4 and 9. So this is the major difference between the codomain and the range. So we should know that the range of a function is always a subset of the codomain, just like we see here. So we should note that always the range is a subset of the codomain. So the range is a subset of the codomain. So we can have codomain as all the elements of set B, but the range are only the sets of the images of elements in set A. So that's the major difference between the codomain and the range. And with this, we are done with the first part of this tutorial. In the next video, we're going to be looking at the types of function, and the following tutorial after that, we're going to be looking at self examples from all these definitions and also the different types of functions that we have.